not necessarily easy, but it is possible. It is possible.
Mm-hmm.
Yeah. Okay.
Yeah.
Let's see.
Yeah, that's very cool.
Thanks. Yeah, I might put this code out there somewhere in case people want to see it. I want to give quick update on progress of the Python debugger.
Mm-hmm.
Okay, so there has been a lot of work into this. So at the moment, maybe give you a quick demo. What is a file that is interesting? Oh, okay. Of course, there's the Fibonacci.
Okay.
Okay, you run it. So this is a custom. It's a modified version of Python. I forked Python and I modified the source code so that when you run a program with this Python, it spits out a log. And at this point, I just recently made a change that when it spits out the log will be called the file name .rewind.
Okay.
I'm calling this tool rewind or Python rewind. So it spits out this log, and then you can run this recreate.py script on this log file, this py rewind file. And what it does is it generates a SQLite database, which is going to be called fib.sqlite. And then with this SQLite database, the recreate script recreates the previous states of the program. And so the database contains all previous states of the program. So we can use our debugger, hopefully, if it's not broken, to step back through the history of this program. Oops.
Oh, I realized the arrow changes direction.
Yeah. I'm still figuring out the reason I added this arrow is to show whether you're after the point of calling this function or before the point of calling this function.
Okay.
I'm trying to make it more intuitive, but I don't think I've totally succeeded. But it's a work in progress. So right now the arrow is pointing up, which means we haven't called this fib function yet on this line.
So you are actually in the line between the last line and this line.
Yeah, exactly. Yeah.
Okay.
So yeah. So anyway, this is the Fibonacci program. It's the simplest one and it doesn't require any data structures. But since then I've made it work for lists and dictionaries and sets, all the common data structures for Python. So let me see. Maybe try the permutation. Let's try the multiplication persistence one. Okay, there's this program I got from Numberphile, the Numberphile YouTube channel. So if I recreate the past for this one, it's actually taking a while. And then I'm gonna debug it. Okay, so I don't know if I want to spend the time explaining this math problem. It's okay. I think I can. So There's a YouTube video if you want to watch this one. It's a really geeky math thing, but you multiply the digits of this number, and this number is 27777. You multiply all of the digits into the number. So and if you get to the point where the result is one single digit, then you're done. But if it's not, so first it breaks up into digits. So now all the digits are in a list now, you see? And then it goes through each digit and multiplies it into the result, you see? It is going through each digit. Now the J is 9 now. That's one of the last two nines. It's multiplying it into this result. And that's the result. It prints it out and then recursively does this to the new result.
Okay.
So this new result, it breaks up into digits again and then multiplies them all into this number. and then the new result is that, and so forth. And the point of all of this is to see how many times you can keep it going before the result is one single digit. Yeah. So anyway, this is a funny math problem, but this shows you the debugger works in this case, and this case is not super complex. It uses lists, and the debugger is working in this case. So I may.
So why it takes a while to generate a SQL file? Is it because it has a lot of state?
Yeah. This is actually really becoming a problem now. So last night I had, so as I ran the recreate script on one of my, so I've been trying various programs that I have written in the past, or I could gather from different sources that are actual Python programs that people wrote. This is one of them. This is an ASCII drawing program. I'll show you quickly. Okay, so this is an ASCII drawing program for drawing using ASCII characters. You can use the cursor to move around, and then you can just type the letter you want.
Oh, I love this program.
So because my son Marty was interested in Python programming, and I showed him ASCII art. I made this thing hoping that he would use it. But anyway, so I made this program. I tried to run the debugger on it. And the problem is it took, first of all, there was a whole bunch of various issues, various bugs, errors that I ran into, which some of them I used the test case simplification thing to solve it. But then after I got through all of those, the recreate script ran really slowly, or just took a really long time. And this was last night, and I finally took so long that I was like, okay, which is why I had it. Oh, actually, I don't want to do it on that because I already created. Anyway, I ran it on it, and I basically it got so slow that I decided to make it print out the progress. And when I printed out the progress, I did an estimation to see how long it would finish the whole thing, and it would have taken 3 hours to finish the whole thing. And I thought, I'm about to go to sleep. Let's keep it running. Well, I see if it will finish while I sleep, right? And then this morning I woke up and then I saw that my hard drive has ran out of disk space. And that was the error that it ended with. So basically, it has generated a 20 gigabyte file as that SQLite database. Where is it? This one. This is a 22 gigabyte
Oh, wow.
database that it was generating, and it
Uh-huh.
it, it didn't even finish. It was in the middle, and it ran out of space in the middle. And I was looking at the content of this database, and one of the things that obviously jumped out at me is some of the entries in this object table are extremely large. This is a heap. This is a representation of a heap, the
Uh-huh.
current state of the heap at that
Mm-hmm.
point. And basically, there are so many heap objects in this program that each time any heap object updated, I would generate another sort of entry that is like this. It, like with maybe one or two of the things in this map.
Oh, because you want to make it immutable.
Yeah,
Yeah.
yeah. So this is an obvious problem, and this is so next step is like figure out how to solve this problem. Yeah.
I have a question. Is it possible to directly insert rows into like maybe like a database on the internet that has much more room when you go through when you inside the thing that inside the Python compiler, instead of generate a log and then use the log to generate a SQLite file, can we just directly insert stuff? Because you say you don't go back, you don't look back, right? You don't do like a look ahead or whatever. So
Mm-hmm.
is it possible to directly just insert while the program is running?
Yes, it is. You're thinking just offload it to the cloud so that
Yeah, exactly.
it's not our problem.
Yeah,
Um,
exactly.
well,
Offload it.
um, I mean, yeah, assuming your computer in the cloud has enough disk space, or well, the immediate problem is that it's using a lot of disk space, and I think that has to be solved though, because it's inefficiently using disk space right now, right? Like
Uh-huh.
this is a very very large chunk of string of data,
Uh-huh.
and each time any of the heap objects change, I'm gonna enter another row in the database that's just as long.
Uh-huh.
Like
Well,
like
I guess another potential way will be like using some sort of reference.
yeah,
But I don't know how that will work though. It's like you change one string in this long object, and then but the rest of it is referencing something else.
yeah. So this is definitely a naive implementation. What the thing that I was planning on using initially is we can instead of having one gigantic dictionary like this,
Mm-hmm.
we could separate it into a multi-level map. It's like a tree.
Okay.
We could separate this thing into a tree, which
Okay.
is there's been research on how to make multi-level maps based on trees.
Okay.
And if it was a tree instead of a map, instead of a flat map, then what you could do is every time you make a mutation or modification to the tree, you keep the nodes that don't change, and then you start at the one that you do want to change, and then you basically build a new version of the tree, starting at the root, and then so the root is gonna be new, and
Mm-hmm.
then but for all the parts that the root has to point to that haven't changed, you point to the old ones. So it's like if you need to change a node like that's 4 levels down within the tree, then you have to create a new node for each of its ancestors have to be new nodes.
It's
But
like the immutable set, right?
yeah, it's exactly. It's like the way you do immutable binary trees, for example.
Okay.
You have to create new nodes for its ancestors, but everything else can can point to the previous existing nodes because those things haven't changed. So I could do something like this. I'm also considering maybe each of these mappings is just a row in a database. And then when you update it, maybe there's like for each heap, this is called a heap ID. But the heap ID is pointing to like some object in the heap, and then when that object changes, then this immutable object ID updates, right? This is a heap ID pointing to an immutable object ID.
But you will still have all these IDs in this entry that's in here, right? You don't have the value, but you still have the ID.
I don't have, yeah, all of these are only IDs. The values are elsewhere in this table. The immutable IDs are IDs back to this table, an object inside this table.
Wow.
But yeah, so I'm gonna think about how to solve this problem. I had a very similar problem when I was working on that tic-tac-toe game that generated a lot of objects. But yeah, I will have fun working on this problem.
That sounds like an interesting problem.
Yeah,
it's like algorithm at the end. It's like when you wanna improve the performance, and then you just wanna create new algorithm to solve it, so that you don't store like repetitive information, I guess.
Yeah, it's interesting. And you don't really like. I think with performance problems, the best approach to solve to uncover performance problem, like when you're writing code, you're worried about whether this is going to be slow, but when you test it, it's usually okay for the very small data set that you're testing with. The way to work on performance is you just throw some real world data into it to actually get a very, very bad scenario. And this has happened, and it wasn't planned. I had no idea that ASCII drawing program would cause this situation. But the reason it caused this situation is not the code in that program itself. It's actually because the modules that are loaded by the code, like the code uses some modules that cause this. And I don't know which modules exactly, or maybe it's the combinations of a bunch of the modules. They just generate a lot of heap objects in total.
So by module, you mean like external packages?
They're actually like these modules. These modules come right out of the box from Python.
Oh, okay, gotcha.
But some of them are directly implemented natively in C, but a lot of them are not. A lot of them have a lot of Python code, and my logger actually logs the execution within those modules as well.